All, Vinod here from Entrance Engineering Academy. Before going into the video, I just want to say a few things about Entrance Engineering Academy. So, EEA is an online gate preparation portal, and we offer full course for GATE ME and XE. In addition to that, subject courses are also available for ME, XE, CE, and PI. Engineering mathematics course is available for all stream, and in addition to that, we offer online test series for GATE ME and XE also. So this is our website. You can just check out so that you will get to know more about us. And in addition, we have our own Android app and also iOS app, and you can just go through that also to know more about our courses. Okay. And this is our last year, that is GATE 2021 result from XE. And now let us proceed to the video. And this video is taken from online video course of Endurance Engineering Academy. So the next term is mass. Okay. So everyone know about mass in general. Okay, so I don't want to define the basic ideas more. See, basic idea is what? Mass is nothing but amount of matter which is present in a physical, any physical entity. Okay, you just take this. Okay, you just take this. Here it is filled with some solid matter, right? You take a water bottle. Okay, I'm filling it with water. So it is filling with some water molecules. So it's a matter which is of liquid state. I'm removing the water. Now what that water bottle will have? The water bottle will have air. Air is also matter. Still it has some mass. Okay. Now I'm removing all the air. Now what will happen? Vacuum. So vacuum means it doesn't have any mass. Okay. So that is what any amount of matter. The matter may be anything. The matter may be solid, liquid, or gas, or whatever it is. Whatever the quantity, okay, whatever the quantity of matter, that is measured by. That is something which we are going to call it as mass. Okay, so whatever the amount of matter which is present in physical entity, basic definition. Now coming to next, we know that mass is a scalar quantity. We are not going to define any direction for mass. Now coming to the third point, Newton's law. This is something which is very important. From Newton's law or from Newton's experiment, what Newton has found? Newton found that mass is directly proportional to inertia. Mass is directly proportional to inertia. Here this word inert. Okay, here this word inert is very important. So you would have seen the same word somewhere else also. Okay, there it is. I hope you remember. Inert gas. Okay, argon, helium, xenon. Okay, those are inert gases. Inert gases are what? Inert gases. Suppose let us consider an example. Let me take an iron rod or iron material. Okay, I am heating it in the furnace. Okay, I am heating it to some 1000 degrees Celsius or something. Okay, or I am just not heating also. I am just keeping the iron rod. Okay, at some temperature. What will happen? Surrounded by oxygen. Oxygen will come and react with iron and it will form ferrous oxide, that is nothing but rust, right? So oxygen will be more interested and it will be more reactive with ions. But I'll keep iron, okay, very hot iron, maybe 100 degrees Celsius, sorry, maybe 1000 degrees Celsius or 1500 degrees Celsius, and there is argon. What argon will do? Will it react with iron? No. So there will be some resistance offered by argon to react with iron. See, argon will have some resistance against the chemical reaction, and that resistance against the chemical reaction is there, right? And that is why we are calling those gases are inert. So inert means they are going to offer some resistance, and in case of chemistry, the inert gases are going to offer resistance against chemical reactions. Now, coming to this Newton's law, mass is directly proportional to inertia. What is inertia in terms of motion? Because we are dealing with motion, right? So inertia is nothing but simply resistance against motion, or in other word, resistance, or I can say that inertness. Okay, resistance or inertness, both are same. Inertness to undergo change of state of motion. Okay, change of state of motion. So there will be some resistance to change the state of the motion. I will give you some examples so that you can understand it much better way. Okay, so resistance or inertness to undergo the change of state of motion. Okay, so it won't change its state of motion easily. There will be some resistance against changing its state. Let us take an example. Okay, so there is a person who is riding a bike. Okay, maybe motorbike, a very small motorbike. You can consider TVS XL. There is another person who is driving a car. Okay, see, both this bike and car, after traveling some distance, they are traveling in a highway, and they forgot to fill the petrol or the petrol tank. So what will happen? It will both of them will travel for some distance. After that, it will get stopped. Now, bicycle person, that is motorbike person, he will simply hold the motorbike. He will just take that motorbike with him without any issues. But what this guy will do, a car guy, obviously he won't able to move it alone. Okay, he needs some 3 or 4 persons for moving it, or at least he needs some help. Okay, so he cannot move it that easily. So this car offers more resistance to change its state of motion. Here, what is the state of motion? Here it is at rest. Okay, so changing from rest, for bringing it to motion, we need more energy, we need more people. But motorcycle, no issues at all. He is just holding it and he is just carrying it. So change of state from rest to motion. Okay, here it is at rest. From rest to motion, it was very difficult for car. I had given another example also in my moment of inertia video. There is one slim person, there is one fatty person. So if we keep race between those two, who is going to win? Obviously, if the fatty person was very fat, like he is very much fat, we will consider 100 kg or something, and slim person was very active. Okay, he is very slim. So obviously, the slim person can win first. The slim person can move faster, right? So why it is happening? Because of the inertia of his own, inertia due to his own mass. Okay, so because of his own mass, that that fatty person not able to travel faster. Okay, so he is not able to change his state faster. I will give another example. Consider that there was a bridge here. Okay, there was a bridge, and in between the bridge there was some river flowing. Okay, so let us consider there is one guy sitting here. Okay, there is one guy sitting here. Okay, and first one person is coming. He is just parking bicycle. Okay, he is just parking the bicycle like not in a proper position. He is just parking at this edge of the cliff. What will happen? Automatically this bicycle will start moving down, right? This person is sitting in the cliff. He is sitting near the bridge. What he will do? He will, this bridge is decreasing. Okay, it's like decreasing the slope. So this person is this bike was moving down. Okay, so suddenly this person sees the cycle. It's not a bike, it's a cycle. So he just hits the cycle with his leg, and then he hold it and he just kept it here. Okay, that he did it very easily. Okay, very easily he did it. Now imagine there is a lorry which I am keeping it here. Okay, there is one lorry, I am keeping it here, and again I am not parking it properly. So because of this slope, it started to move down. Now what he will do? Will he go and will he kick and will he stop it? Obviously it's not possible. If he tries to do it, he is going to be no more. So he will also start running. Okay, so the reason is here this cycle has lesser mass. So now for changing the state again from motion to rest. Okay, here initially the cycle was moving, and for changing its state from motion to rest was easy. Resistance was less. But lorry, heavy mass, obviously not able to. We won't able to stop it at a shorter time. It will take more time or it's not possible to stop. There will be huge resistance for changing its state of motion. Okay, so from motion to rest also it is not possible. That is what I am saying. If mass is more, if the lorry, that is huge mass, was traveling with some speed, it is difficult for changing its state. It is difficult for making it to it's difficult for a lorry to stop. Okay, so from motion to rest also it is difficult. Now coming to another example, if you take car and if you take lorry, okay, both are traveling in a highway. What will happen? Lorry, they will travel at some constant speed, right? Maybe 45, 50, 55, 60, some constant speed. They won't increase the speed or they won't decrease the speed at a very high rate. But if you take car, they can easily increase their speed, they can easily decrease the speed. You can take car as an example or bike as an example. Easily they will increase the speed, easily they will decrease the speed. They can go at a very high speed. Okay, so that can happen. The reason again, inertia. Okay, so changing the state also, changing from one motion state to another state. Okay, changing from state of one motion to another motion. Initially, if the car is traveling at a slow velocity or slow speed, it can change to fast velocity immediately. But lorry, it is not possible. The reason is, for lorry, inertia is more because mass is more in case of lorry. That is it. That's it. Inertia, okay, it is resistance or inertness to undergo the change of state of motion. Either the change of state may be from rest to motion, as in this example, or motion to rest. Okay, resistance will be more for a higher mass body, or from one state of motion to another state of motion, from lower speed to higher speed. That is also difficult for a body with a higher mass. Okay, so that is what Newton's experiment is saying. So mass is directly proportional to inertia. So if a body has more mass, then there is going to be more resistance.